You're not here to listen to me vamp, though. You're here to see some lemurs. Kind of in awe of all the work that Brandon has put into his talks over the years, and excited to see this next version. For those of you who haven't had an opportunity to see Brandon speak, again, I'm just a really big fan of the people that we bring up on stage, and hopefully we'll see you up here in the future. But now it's Brandon's turn. So Brandon is a senior staff engineer at One Medical. He's an artist turned programmer who teaches Ruby with a series of colorful cartoon lemurs going on storybook adventures. These talks have featured everything from conducting symphony orchestras on cell phones to the deepest and darkest corners of the Ruby programming language. This time, he's brought something special to share, and he looks forward to sharing it all with you. So without further ado, everyone, please welcome to the stage, Brandon Weaver.
So let's go ahead and get started. You see, I have a magic little book here. And this magic little book has a nifty little trick. Is that as soon as I turn this, we're going to see the slides start turning over here as well. So hello, so glad you can make it today. Grab a seat because we're about to get started. But first, who am I? Well, simply put, my name is Brandon. I love Ruby, and I'm here to share that with you today. And right now, I'm over at Amazon's One Medical, delivering provider efficiency and trying to take care of folks. And today, I brought something special. A story I've wanted to tell for quite a while, but it was very hard to fit into a typical talk. A story I deeply enjoyed writing, and I hope that you will enjoy it as well. But before that, a quick note. Each major section of the talk, whether it's a story segment or a code segment, along with the lemurs that we speak in each section, you're going to see a little pop-up. If it's a code segment, there will be a QR code on that main slide, and all subsequent code slides in that section will point to the same file with examples. If you miss one, don't worry. We are going to post it in a Slack channel called Red in Fantasyland, and you can also find them after the talk. With that said, though, shall we go ahead and get started? Deep in the library. We find ourselves in the grand city library of the Master Violet, an infinite well of information and wisdom in the world of lemurs. Why the library? Well, you see, there's a particularly naughty lemur you might see down there named Indigo, who's been repeatedly banned from the library, along with his friend the Escher cat. It had been 6 years since they last had the chance to teach functional programming. By golly, it was time to do it again. And if they're going to teach functional programming, well, they need something special this time. They couldn't be outdone by the Lord Crimson or any of the other lemurs, and to do that, they needed to go deep. Deep into the furthest reaches of the library where all the real fun books were hidden, where light begun to fade and the magic around the swell crackling in the air like stars in the sky. Now, what was the best sign that something was truly fun? Well, of course, the more chains and locks and spells and wards, the better. If Violet had gone through that much trouble and care to keep them away, then that's exactly the book they want. So kind of her to make it easy to pick, wasn't it? Very considerate. And in this forbidden cove, there was one book which stood out, marked with the sacred lambda symbol and under the protection of lemurs of a foreign land very far away from Ruby. One sealed with ancient magics and binding spells locked tightly in chains, and on its cover we can faintly make out the text, Wonderworld. Upon opening the book, a blue fog emerges, the air in the room stirs, and all lanterns extinguish. There are deep magics here, secret design patterns for the lands of functional programming, very different than what we might know from object-oriented languages. There are the functions, mappable and reducible types, and something else beyond even them that combined everything, a name which must not be spoken aloud, because who cares? Rules, rules, rules. Who in the world reads all these warnings anyway? But the rest of this book? Indigo cackles to himself, delighted, discarding all the warning notes and warding spells as he exclaims, "The rest of this book is perfect!" But they hear a noise, a soft thump of slippers, and light coming around the corner. The master library, Violet, was awake. She enters the deeper parts of the library, lantern in hand, trying to figure out what in the world is going on, why so many alarms have triggered. There she finds Indigo and the Escher cat with a particularly dangerous book. "What exactly are you?" Violet was cut off. "It's Escher, time to make an exit. Let's go," whispered Indigo. Violet, annoyed, yells out after them, Indigo, Escher, don't you dare! We cannot have another eval incident, especially not another mess with metaprogramming. So the Escher cat smiled mischievously. With a snap of its paw, the two began to make their miraculous getaway, fading into dust. Violet sighed and goes to look at the place where the book once was, seals undone and multiple months of binding spells broken. The one book which must never be opened, the one subject which must never be taught, that will render its reader incapable of ever teaching it again. A subject no wise lemur would ever dare touch, lest they be banished to the far lands. All that remained was a scribbled note with a smiley face and a quickly drawn thanks. So Violet takes a moment, collecting herself. As the shadows behind her begin to stir and coalesce, behind her several figures with hoods drawn over their faces. The owners of the book come from the distant functional lands. They point to the missing book, and the head lemur simply says, It must be found, for there are some things the lemurs of this land are not ready for, and something which must not be unleashed upon its pages. Once before, the Lord Crimson visited our lands to learn from it, but even he was not foolish enough to teach it here. The words must not be spoken. Violet agrees to this and answers, Yes, we can only hope that it's retrieved before that thing is let loose upon the world. An ancient creature from time immaterial, grand in its wisdom and terrifying in its potential, who cannot be comprehended by the normal lemur. The only question, of course, was where Indigo might unleash such a force, and what, if anything, could be done to stop him and the Escher cat. They could only hope no one would be caught up in such a catastrophe, completely unaware. A new adventure. Speaking of unaware, we find our friend Red the Lemur studying in a tiny forest grotto. He was just finishing up his book, searching for his next enlightenment, but he always found himself returning to the classics. He sighed and looked up to see Saffron, the great tailor, sprinting right through with bolts of silk over his shoulder. As he dashed by, he heard him repeating something about tea parties and needing to be early. A piece of paper slipped out of his bundle and landed in front of Red. Early, early, early. Why was he so obsessed with being early? And what was this about a tea party? Red was confused, sat down his book, and began to chase after Saffron. Wait, where are you going? Why are you in such a hurry? Asked Red. So many outfits to make, so many costumes to make. I need to be there early before the party starts. Anything through VVVIPs to the tailor shop, yelled Saffron as he blew on by. What tea party? Asked Red. Check your invitation. They insisted you be invited as a guest of honor, said Saffron. Red stopped and took a look at the invitation and sighed to himself and saw what appeared to be a scroll of crayon with arrows pointing at what looks like a staircase. And when he looked up, Saffron was gone, nowhere to be seen, and in front of him was a giant tree with a hole in its center and a suspiciously well-designed sign that read Fantasyland. Was it a trap? Probably. Did Red particularly care? Probably not, because there's far more fun in exploring and pushing the limits of what we know than sitting still and accepting things as they are. And he wasn't going to miss out on what this adventure was for the world. So he found himself climbing through a labyrinth of stairs, right side, left side, upside, down side. Which way was even up? He found himself more and more lost, but at the same time approaching something until he found himself at a gateway on the precipice of a brand new strange land. The Forest of Functions. Upon exiting the strange labyrinth, he finds himself in a forest unlike anything he's seen before. And in that forest, he can see a fire in the distance and a few familiar voices. The Master Lavender and Crimson were sitting by a fire, drinking tea.
Was told Indigo was up to something again. You think we should stop it?
He heard Lavender saying. Why? It seems interesting so far, and who knows what else him and that cat came up with, said Crimson.
It appears we have a guest. Shall we serve him some tea? Said Lavender. Just, not a party. We shouldn't interrupt those for later.
Red emerged from the forest, confused, and asked, What in the world is going on in this place? Where are we?
The two looked at each other and began to laugh, and then Crimson answered,
It appears our friend Indigo and the Escher cat are having their fun, and they've been so kind as to involve us in their little plans to get you ready.
And also to supply tea for the little party, responded Lavender.
Red looked confused at this.
To start out with, what is a function?
Well, a lambda or a proc, right?
Strictly speaking, yes, but what are they used for?
The problem in Ruby is that we see it as almost a foreign part of the language, but in my adventures in lands of functional lemurs, I found something else entirely. What do you mean by that? I mean that with only functions, if you're so inclined, you could build entire programs by gluing them together. Should we take a look real quick? Let's go ahead and start out with some basic functions. So in Ruby, there are a few types of functions, but generally they're categorized into two types, lambdas and procs. In this talk, we'll be focusing on lambdas when writing explicit functions, but there's another case we'll be getting to shortly where procs are more common. Now, functional programming works by gluing together smaller functions to do larger tasks, and Ruby provides us with just the glue to do that. In this case, we have two functions, one which adds 5 and one which multiplies by 3. Ruby can glue these two functions together using something called functional composition, and the operator is that double angle bracket that you see down there. In this case, we can glue together the idea of adding 5 and multiplying 3 to make a new function, which is add 5 then multiply 3. We can call that to verify and see that it does indeed work. And you can also see in parentheses what that is actually doing. You might think this looks very foreign. Why in the world would we do this in Ruby? Well, you might think it's foreign. And you might think you don't really care about functions, but you already use them and they're everywhere in Ruby. And they're called blocks. Now, this probably looks very familiar, and it is in fact a function, perhaps by a different name. But a block function, they're all functions. And in the end, you're already using them everywhere. Block functions are actually procs under the hood as well, showing us that the second type of function is indeed used. In this case, they allow us to select out only the even numbers of a list. Now, if we wanted to make our own method, which takes in a block function like select, we could do something very much like this. But we'll go ahead and step through that as well. In this case, we start with a function, and we care whether or not that function returns truthy or falsy. So we're going to call it there for each item of the array. Really, we could name it whatever we want. But the question is, what is being used for? In this case, we use it to find the values in an array which are even. And if that happens to be true, we add that to a new array, which is then going to be returned at the end of the method. Now, as to how that would work, we'll step through that a little bit differently now. Let's take a look at what happens in this method and how the values flow through select step by step. For our first value, 1, we check if it's even. It's not, so it does not go into the new array. For the second value, 2, it is indeed even, so we add that to the new array. And for the third value, 3, it's not even either, so we do not add that to the array, which gives us back our final new array of 2. But one thing to keep in mind with Ruby is there are many, many different ways to do something. Which way is right? Which way is wrong? Longhand, shorthand, select, filter, explicit, implicit. Really, it depends, doesn't it? Which answer is correct depends on the code base you're working in and the people you're working with. Aim first and foremost to be understood and readable rather than being clever.
Beyond that, there are many lessons from many other languages. Some very different philosophies you might find in Ruby. All are valuable, certainly, but be careful not to become dogmatic.
And with all that said, there are others to meet and lessons to be learned ahead of you from friends old and new alike, said Crimson. So with that, Red wandered on to the next area.
You think we should warn him about the... Lavender was cut off.
Nah, it'll be more fun if they find out themselves,
answered Crimson.
The mappable meadows. So we find Red entering the mappable meadows, a place filled with flowers and plants of all kinds. And there ahead he finds Chartreuse, his master from many years past that taught him the ways of map. But this is a different place at a different time. It's been what now, Red? 6 years? My, how time flies and the young ones grow. And so too does our understanding of what we think we already comprehend. What do you mean, Master? Last time we spoke, you taught me about map, but wasn't implementing it with reduce all there was to learn? What is map? Well, of course, it's using a block function to transform every element to list, isn't it? Yes, that's true, but there's far more to it. Let's take a look. To start out with, we'll take a look at map. Consider this example. We know that we can double every element of a list by applying a function that takes a parameter v and returns v times 2, but how do we know it does that? Why do we know it does that? How do we know that that block function is going to double every element in a list? For an array, it might look a little bit like this, certainly, but in doing so, we notice something very interesting, is that we have an array in and we also have an array out. That's because using map in the context of Ruby's array returns a new array with every value transformed by that function. But what if it were a different type? Then the context would change, and what map does would change along with it. I'm not entirely sure. What would happen in different contexts? Let's suppose that we define map for a string. What might it look like? Now again, the way we define map changes depending on the class and the context we're working with. So in the case of a string, perhaps map would make a new string. And then stepping through that, we would take and iterate every character of the current string, and we would append to a new string by calling that function on each individual character, adding that to the new string, and eventually we'd return that from the end of the method, which we would call like this. Now, it gives us something that looks very similar to a map function for an array, but I think we can go a little bit further into our explanation. Perhaps we could define map on string itself. Now, certainly I would not encourage this, but we're discovering things today. Much like array derives map from a numeral, we can define our own map directly in class. Now, again, I would not suggest doing this except as an example. The notable difference here is that we're getting characters directly from self, which, while not required to put self in there, does make it clear where it's coming from. The other is that we're directly calling map on string itself, which gives us something a bit more ergonomic, but I think we could go further even still. We could implement map using map if we really wanted to. So if we look at our original code from before, we could instead use map to implement map. Now, there's certainly no rule against it, and it would shorten our code a good deal too. The two differences here to look out for is now we're using map, but we're also using join to add the characters back together to give us a string. In fact, we could maybe even go further, and we could condense our example using shorthand. Now, we can take our current code here, which is using map, and then we can directly pass the function to it instead of trying to call it manually. Now, that all said, we should probably not monkey patch core classes, should we? So what other options might we have? Well, modules might be a good start. What if we wrap that in a module instead? We can take our monkey patch class and extract it into a new module, and this will look very similar to what we already have. The problem with this is if we want to map more than once, it quickly becomes unwieldy. So we're going to have to find another option. What if instead we wrapped our string in a class of our own making, where we define the context and we define the rules of how it operates? Maybe we have a string characters class, which has our own rules of how we decide to do map. We could even define map on it directly, but this map has a problem. Do you see what it might be? It returns back a string. So what happens if you call map on a string that's not been monkey patched? It means that code like this would error out and say string has no map. That's because we went outside of the context of the class which knew how to map and returned a string instead. So what are we to do then? Well, there's a nifty little idea, which is that we can bring it back into the context of our string characters class by using a method we can call wrap. Now, that can be self.class.new or it can be stringCharacters.new, but this is the more generic version. It's a way to take a string and put it back into the context of our string characters class. And to use it, we would add a wrap around our implementation of map, and then it would work just as we expect it to. But there's one thing to keep in mind. The value is still in the context of our string characters class. We need to get it back out. Having our own rules is great, but our program probably doesn't want string characters. It probably wants strings, so how do we get it back out? Well, we can get it back out by calling value on it. So taking a look back at our implementation, it looks like we have something which could be used elsewhere, no? Like wrap and the idea of a value. What if we pulled that into our own enumerable-like module. Like let's say mappable to represent something which can be mapped. This is a basic example for making our own context, but it serves a point. By doing so, our implementation of string characters is shortened to this. But what's more is it allows for us to potentially make, say, a string words class. Now, granted, this is naive, but it serves a point. Or maybe even we have a string lines one. The point is this behavior is very repeatable. And by establishing our own rules for map, we can do a lot of things which might not make sense for direct classes like, say, string or array. We can even use this idea for something completely different. Like, let's say, take this single white flower here. Could this also be mappable? Perhaps in the context of a flower, the color happens to be the value inside of it. And if we take a look, we can see that mapping in this context means to transform the color and return a new flower. Now, the mistake a lot of people make is that map can only be called on collections, right? No, not at all. Map can be called on anything. Anything is technically transformable as long as it follows a few rules. To test that, we could take colors, like let's say the colors white and red here, and we can create a new flower where we mix 0% white with 100% red, effectively painting this flower red. Now, there was once a song I'd heard from a movie long ago about painting flowers red, but that's neither here nor there. But now that we have an idea of what it means for something to be mappable, there are also a few rules we must keep in mind, ones you might already have noticed the reason for earlier. Now, there are 3 rules we need to keep in mind for things which happen to be mappable. The first rule is that doing nothing should, unsurprisingly, do nothing. What do I mean by that? Well, let's start out by defining equality for a mappable module. For something as mappable to be equal, it should be the same type as well as have the same value inside of it. So let's take an example string like hey world and make an interesting little function here which does nothing. It takes in a parameter v and returns back v out the other end. And we'll also make a new string characters instance and we'll call it a context here. So afterwards we check if doing nothing to that wrapper does in fact do nothing and we're greeted with a true response. That means that doing nothing in the context of something which is mappable does, well, nothing. Now this might sound boring, but why do we care about this? Back to our module context, and with string characters before we added wrap, that would have failed. If it fails, it means we're not returning the same type, and we can think of it as a baseline test to ensure our mappable class works as expected. Rule 2 is if we call map twice with 2 different functions, we should get back the same result as if we compose the 2 and called map once instead. Now, what do I mean by that? Let's say we had 2 functions, one which wrapped a character in brackets and one which got the next successor character afterwards, to where a.successor would end up being b. And let's take back our example of hey world and our context here for an experiment and test that if mapping twice to each function separately returns the same as if we compose the 2 functions. Why do we care about this? Because after all, these are just functions. Our string characters class should not be doing anything unexpected to them like mutation or extra steps. No. Or more simply, we do not wish to surprise people using it. What you see is what you get, and there should be no surprises. We may be able to define our own rules, but functions also have their own rules, so we should be very respectful of that. And we should be careful not to break them and do unexpected things. Though, in some cases, Ruby does not exactly hold true with this, such as hashes. Why exactly is that, do you suppose? Well, in the case of Ruby's hash, it doesn't behave this way because it inherits map from enumerable, and that means it's going to return an array instead. We must be careful of this, but Ruby's hash also has a different method here, which is toHash or toH, which behaves a lot more like what we might expect. Now, does this mean we should change map on all hashes? No, because too much already relies on this behavior and changing it would be dangerous. So you see, Red, there's far more to map than there appears to be, an entire world of mappable things to discover out there in the wide world of Ruby. We've only covered a small part of their potential. Consider it a pattern to be used when you find things you program with similar shapes that follow these rules. Now, this is all fascinating, but where are we going with this? Why learn about context and values and mapping? I'm confused where you're going. Now that's a lesson you'll be learning soon enough, but it's not mine to teach. Journey on to the tea party where you'll find answers to your questions there. So with that, Red had learned more about map and began walking to his next destination. the reducible residence. As the colors transition from greens to golds, Red finds himself on the path to a tailor shop on the edge of the forest, a tailor shop that looked almost exactly like the one from Lavenville, owned by Saffron. But how in the world did he get here of all places? So Red went to take a look, and there at the end of the path he sees a shop with various outfits and fabrics littered everywhere in an eclectic smattering. Saffron had been busy, and just then Red saw Saffron bolt inside, fabric flying everywhere behind him, still droning about the tea party. What party, and why was everything about being so early? So Red enters the shop, and inside he finds Saffron hurriedly finishing multiple outfits of all cuts and styles, from fine party suits to imperial dresses and even a hat for a cat. So he had to ask, what in the world are you doing here, Saffron? Preparing for the party, of course. I'm a lemur of my word, and I have a reputation for promptness to uphold, Red, Saffron stated proudly. Well, I suppose I'll be on my way then. If you could just point me to the party up. No, you didn't think you came here for no reason, did you? Come now, you're going to help me, and to do that, we're going to need to teach you about what it means to be reducible. Red flinched, but before he could make for the door, Saffron was already starting into his lecture. And what better way than to start to answer the question of what does it mean to reduce? Of course, we have a reduce method in Ruby, but it's not often used directly, so let's take a little bit of a look at it and see what exactly it's doing here. If you've never used reduce, this syntax is going to look very odd indeed. What happens to the array? What's at 0 there? And what exactly is that block function doing? Well, let's step through it and see what exactly it's doing. We can take a look at the values of a and v for each step of this reduce. Now, granted this is condensed for slide length, but we'll give you some explanations in a moment. We start out with our base case of 0, the first argument to reduce. While we name it a here, it stands for accumulator, and this is going to be accumulating values as we reduce into one thing. And then we take 1, which is our first value in the array, as v. And what we're doing is we're adding those together to get back a result of 1. So what do we do with that result? Well, we take it to the next iteration, and now that's the new iterator, the new accumulator, excuse me. And we start again with that, and then we add 2 to it, which gives us 3, which we then bring back again to be the next accumulator, and then we add 3 to that to get back 6. So what happens when we run out of numbers? Well, that's our result right there. It's 6. And it's returned from reduce. So taking a note from the top, we are effectively doing what we mentioned earlier, which is adding 0 plus 1 plus 2 plus 3. Or more accurately, we're combining in the leftward direction. Given that, it's not surprising some other languages call reduce by another name, which is fold left. But isn't that just the same as sum? Asked Red. Exactly right, but why? There's something very interesting here to explore. So Ruby's sum method is far more common than reduce, and you're probably more likely to see it. So what exactly is that doing? It simplifies a lot of what reduce can do. I mean, there's a single call there. You don't need to care about a block. You don't need to care about the 0. You don't need to care about anything else, do you? And after all, it's just the same as saying 1 plus 2 plus 3, right? Well, you see there's an interesting property here which might look familiar. What do you suppose might happen if you summed nothing? What value do you think might it get? Exactly right. It turns out you get back 0, that empty value that we happened to mention earlier, which means that what we're actually doing is something more like 0 plus 1 plus 2 plus 3, or condensing it back down, again, 0 plus 1 plus 2 plus 3. But why does it work? What magic is afoot here? Well, that's where we are going to, and I apologize, get into a smidgen of math. Not much, though. So let's say that we took 2 numbers. We can add them together and get back another number. Which is interesting is that if you join 2 numbers together, you get back another number. But there's a particularly interesting number in the context here of if we add it to any number, we get back that same number. What might that number be in the context of addition, do you suppose? Exactly right. In the context of numbers in addition, the empty value would be 0, but let's say we change the context a little bit. Because what matters here is not that we're dealing with numbers, but the operation we use to join them together. Like, let's say instead of adding numbers, we happen to multiply them. Instead, by saying multiplying 2 and 3 gives us back 6. If I happen to ask you what was empty in this context, is it the same as addition? Exactly right. If we happen to do this, I suppose not. So that means that empty is very context dependent on what the type is, as well as what way you use to join them together. So in the context of multiplication with numbers, that means that we instead have the value 1 to get products. and we have things working again. So we can add numbers together, great, but is that all it can do? Who said anything about it only applying to numbers? There's certainly other types which are also reducible. We already know about a few ways which numbers are reducible, yes. And we can even shorthand that because we know how it works, but reduce goes far beyond that. Here are a few more examples of some basic types you might see and how they might reduce, like string has an empty string and plus, or array has an empty array and plus, or hash has an empty hash and merge. Active record has any scope and all. All of these things happen to be reducible, and we can even get a few examples here to prove that's the case. But there's one more type which is even more interesting, which is that functions are also reducible via composition and gluing them together with that interesting little function which does nothing. Just remember, leftward composition goes backwards what you might think. So if we do it in this direction, we're going to get the first last and last first, which is going to give us this order. But if we flip that around, Ruby has two ways to compose. We're going to see that it actually changes the output. So do be careful here of what you get as results. When adding numbers, we get, but the direction is going to look far more familiar to Ruby and Elixir programmers by using forward compose instead of the other way. So if this is a pattern, perhaps we could look into generalizing it. Perhaps we want our own version of something which is reducible, much like mappable. To do what we need is we need an empty value and a way to join two values, and for our convenience sakes, a reduce method. So this doesn't look too foreign right now, is that we have an empty of 0, a join which adds two numbers together, and reduce which reduces into that empty value and uses a join there. But if we flip this around to multiplication, we now notice that empty changes and join changes along with it because the context has changed. We're not talking about integer addition anymore. Now we can also make this into a more general module in something like this. And that we need to define our own version of empty, which is why we have a not implemented error here, because you do need to do that for yourself. Join, we're going to assume that maybe they have a plus class and be reasonable about it. And reduce, well, most classes won't need to redefine this, so they get that for free. So instead of using include, we use extend. Well, what's the difference? We're extending this into the class. And the reason is because we're working on many things instead of just one thing. In the context of adding addition, we don't need to overwrite join or reduce, but we do need to define what empty means in this context. The same way as we would need to redefine empty to be something different for product, and join would be different because we're using multiplication instead. Now, as with mappable, there are a few rules to observe here and something that makes it reducible. Rule 1 is that we have a given type like numbers and a way to combine two numbers that gives us back another number. Why is this important? Because we can't predictably keep combining things if the types aren't the same. The second rule is that as long as we retain the same order, we can group these conditions or joins together however in the world we want and get back the same result. Why does this matter? It means we can have intermediary results stored in variables, or if we really wanted to, we could parallelize it to thousands of computers using something called MapReduce. We just need to retain that same order. Now, a particularly clever person might note that for addition, the order doesn't matter at all, and you're correct, but that is something beyond the scope of this talk. The third rule is for something to be reducible, there should be an empty value of the same type that if you combine it with any other value, you should get that value back. Why does this matter? Well, what do you do if you sum an empty array? It matters that we have a reasonable default to fall back on in the sense of the context of what we're joining together. Can you imagine if enumerable didn't give us back an empty array if we had no elements back after select? It'd be chaos. You'd be rescuing everywhere. We might as well program Java at that point. So let's start with a little bit more complex class, like move, which we can represent movement on a grid using data.define. Think of this as just a quick initializer, which has the properties x and y, attribute readers, and some other nice properties like equality. We can create a new move just like any other class, but we could also shorthand that using square brackets here as well. And given it extends reducible, that also means we have a reduce method for free that we can use here. But the question is, do the rules still hold with that empty of 0, 0? Well, checking on them, we can see this is true. We can add two moves together and get back another move. We can group them in any order, in the same order, and get back the same result. And there is an empty element which is not going to do anything. Or let's say we did something even more interesting, like let's say a clock. Did you know a clock happens to be reducible? I know, right? It always loops back around from 12 to 1. So in this case, the way we add things together is different. in that we add the times together, but we modulo 12, which means if you have 13, it goes back to 1. If you have 14, it goes back to 2, and so on and so forth. The rest probably looks similar to the past example, and you would be very correct. But does it hold? And the answer is yes, the rules do hold for this as well. So as you can see, reduce is a very powerful idea, and the idea of something being reducible could apply in a great many cases. Now, this is all fascinating, but how in the world do you have an exact replica of your tailor shop here? Isn't that horribly expensive? Asked Red. I made Indigo and Eschercat earn that VVVIP status, that's how. A few more rush orders like this, and I'll have 20 shops. With that, Red sighed and left the shop. But no sooner than he left did the air crackle, and Indigo and Eschercat emerged from the closet in a cloud of dust. I'm afraid your aim needs some work there, dear Escher, but we got here all the same, so thank you, friend. Now, I need to ask, Saffron, are we ready? Anything for the VVVIPs, come right this way, sir, and we'll be off and away long before Red finds his way to the party. I made sure to add a few small detours to your map. Oh, you are naughty. I like you even more now. And I hope you like these outfits as well. Saffron opened the closet, and Indigo and Escher stared wide-eyed. You, sir, are a master. Put it on our cards. The tea party. And now a special guest, a convenient drink of water. We find ourselves in a forest, but something feels wrong here. We find Red very lost, trying to follow the map and the signs, but the forest belongs to a particularly mischievous cat named Escher. Where have I ended up? Surely I've passed this tree many times already, said Red. As he grumbles, we see the Escher cat changing every single one of the signs whenever Red stops paying attention, always just out of sight and always gone right before Red turns to look. So we see Red turning and fretting and wandering until at the edge of the forest, we see a thumbs up from Indigo and the Escher cat smiling somewhere in the ether. So Red whipped around to see the Escher cat flipping a sign, but Escher wasn't the least bit bothered by this, casually flipping the sign slowly and grinning from ear to ear, tapping away at the sign. Now hold on there, you've been leading me around in circles for at least... And with a wink, the Escher cat disappeared, leaving the sign pointing towards the path to the end of the forest, illuminated in a strange glow. Well, we certainly could have started with that. Now then, and with that, Red entered. So many lemurs, old friends and new, all colors and studies, all celebrating over tea prepared by Lavender, and all turned to greet him with cups raised high. Welcome to the tea party, Red, they said in unison as they turned to the roll of drums behind them. And as Indigo descended onto the main table, floating down from the sky with an umbrella, and landing in a puff of smoke, a merry unconference to you, dearest Red, a merry unconference indeed. We've been expecting you, young Red, and my, have we waited for this day. Come, right here, right next to me. So Red walked over to Indigo. I do hope you've had fun so far, and I assure you every bit of what you've learned so far is in fact very necessary for the next lesson. What do you mean all those things are related? For some reason I don't believe you. Yes and no. True enough, but you'll know more as we dive in further. Shall we go ahead and get started? Let's start with the idea of something being falsy. Let's say that we had this code. If you wanted to cache it, what might you do? Your initial reaction might be something a little bit like this, but there's a slight problem here. Can you see what it might be? What happens if that API method returns false? And even more, what if that false is a legitimate result? Even worse, what if it was a terribly expensive call that took several minutes to operate? As it turns out, context is a very useful thing. And in this case, we can use the context of ready-to-brew instance variables have not been set yet on this class to determine whether or not we should call the API to get a value. But this does break object shapes later, so do be careful. Without that context, though, we have a false value. Why wouldn't we try again? Now, consider HTTP responses for a moment, which have a very interesting property to them. Let's say we had a response with some JSON and response code of 200. Just looking at the body, we might be able to guess whether something was successful. But with the status code, we don't have to guess because it gives us additional context to make a decision based on what that status code is. Should we process the data? Should we be handling errors? Should we be redirecting? Should we be warning the user they did something wrong? Well, now we know. But what if someone breaks those rules? What if someone does something naughty? Normally, whenever we respond and get back a successful 200, we think it's a good value. We can parse it. But that's also not a guarantee, is it? What if someone were to do something insidious, like say, give you an error, it blew up in here? Now that sounds silly. You might think, who in the world would do this? GraphQL will do this. Now, granted, and to be fair, they do this because the request to the server was successful. I will grant them that. But there's no guarantee all the content inside the request at any layer or any depth happens to also be successful because things are complicated. Now, if we had no additional context, no status codes, or even unreliable ones, how in the world do we say whether something is successful or not? Well, for a few examples, that's not a problem. But say you had 100 or even 1,000 more, then it becomes very difficult to manage. Every color you code now needs to know what you mean by success or failure. Is it an empty response? Is it an inline status? Is it a custom error object? Is it empty string? Maybe a string error that you have to pattern match against. Maybe it's a number code you don't know. And that makes it a real quandary, doesn't it? So what do you mean by failure? Well, maybe we mean that it's an exception. Maybe it's a named exception. Maybe it's a custom class, false value, reasonably empty ones. We also don't know. So what if we took all that and made our own idea of a result, which could encapsulate a lot of these ideas for us? But unlike other wrappers, this one has two parts. The first would be the idea of success, which has a value, and a few Boolean methods to tell us whether or not it was a success. So a successful thing should, of course, be a success, and it's not a failure, so that's going to return back false. We could even make a class method to make it easier to create too. But there's also that second branch, which is failure. And that's not going to have a value inside of it. It's going to have an error. Is it successful? No. Is it a failure? Yes. And we could also make a similar class method for it. For a basic example, we might have a method to get data which returns either a success or a failure depending on that status code. And it'll pass the response body directly into that. And we might use it a little bit like this. Looks familiar, doesn't it? But we're not nearly done with that. No, no, no. What if the idea of success happened to be mappable as well? Like, let's say that we map on something successful. What might that look like, do you figure? Well, we could return another success and use the function to transform the value inside of it. But that gets even more interesting, which is what do you suppose happens if you map a failure? You can't really transform an error, can you? It's an error. It means that the program's broken. You shouldn't keep continuing. So we don't. We return back self, which means anytime you call map, it just ignores it, lets it go. Off in the ether, never to be seen again. We don't know where it went. So looking at our previous code, we can now absorb that branch of if a result's successful into map right here and use JSON.parse. If it's successful, it's going to be parsed. If not, you're just going to have that error inside of there. This means we just absorb one part of our conditional into result type, all with the power of mappable. But what if we wanted to absorb the other half? What if we didn't care about the error at all? Maybe we could have a default, kind of like what fetch would do with hashes. Now, in this case, we have a method like value or, which gives default value. What might it look like for success? Well, we already have a value, so why would we return a default? That wouldn't make any sense, so we ignore it. But for failure, much like map for success, they do the opposite. So in this case, we do get back that default. So how is this used? We can take our previous code and we can take that entire failure branch and we can move it into value or, which is if this fails, we get back an empty hash. Now, you might not always want to do this, but you could if you wanted to. No conditionals needed. Now, this is all fascinating, but this is my favorite part. What if we had something that was a success, but whenever we used map on it, it returned another result? Like, let's say that when you order tea, we want to ensure we are actually getting a good deal and we're not getting ripped off because we have a tea party. We need to order a lot of tea. We want to make sure that the quality of the tea is reasonable for the price we get. Like, let's say the tea is rated on a scale of 1 to 5, and we consider $3 fair for each level of quality, or we consider that tea too expensive. Like, in this case, let's say that we had a 5 out of 5 and a good $14 price from Honeydew and Daughters. We'd call that a success with a 2.8 ratio, but wait, what's that response look like? We have a success inside of a success. That can't be right. I'm checking my notes real quick. That can't be right. Huh. But let's try that one more time, just to be sure. Maybe we had an otherwise lovely tea from Forest Mango for $10, but a 3 out of 5 quantity is just not justifiable for a tea party. What happens then? Does this one work? A failure instead of a success? No, this won't do it all. Something here needs to be fixed. That's not going to work. It looks like we have another method which returns a result that we can't return from map, now can we? We need to do something else. Say I wanted my teacup here, and I wanted tea poured into it. What would I do? Would I put the entire teapot inside of it? That would be absurd. You can't fit a teapot into a teacup. Why would you try and put the entire thing in there? Exactly right. It makes no sense, does it? So instead, what if we happened to pour the tea inside the cup instead? We already know the tea's inside the pot, so we can just as easily pour it into a new container. And the same idea can apply to our results as well. Our pour method here is very much like map, except maybe we don't want to wrap it in a result for success. So what do you think it might look like? Well, in this case, we could call the function directly on the value and not wrap it. We can remove the wrapper. But what's interesting about pour here is that you could do that with map as well and implement map using pour, of all things, using our earlier concept of wrap. Even more interesting is we're effectively joining two successes together, which may sound very eerily similar to reducible, doesn't it? And in fact, if we use map, we know that we get another method which will give us the results. So if we try that out again, we'll find that we only have one layer of success and exactly what we'd expect inside of there. But what about failure? It's not doing any wrapping for map because map doesn't really apply to it. So do we just ignore it like the other one? Actually, yes, that's exactly what we're going to do. Back into the ether with you, to be gone and never seen again. And if we tried to use that, we would find that it works exactly as we expect, and we might have an error branch out there which is going to tell us that 4 roast mangoes oolong tea is just too expensive for our party. Fascinating, isn't it? Never thought I'd learn a lesson from a teapot, but I wonder what happens when we try an HTTP requested teapot as well. You know, I've never tried this before, but what do you think might happen? Wait, why? Who comes up with this stuff? What do you mean there's an RFC for it? What's a hypertext coffee pot protocol? This place gives me headaches sometimes. But that gives me an idea for a simpler example. What if we made our own teapot and made it pourable? What does it mean to be pourable? What does it mean for that thing to also be mappable or reducible? Well, it turns out a lot. So let's start making our own idea of a pourable interface and see how the teapot might implement it. If we remember back to what mappable looked like, we're given this base. How might pourable come from it? Well, interestingly enough, we can include mappable and take a lot of that. We can even implement map by using wrap and pour on that method if we want. Now, how is this reducible, you might ask? Well, we'll get to that in a moment once we cover the rules, but you might already be able to spot some of it. So let's say we have a teapot, which is pourable. If we use map on it, on a teapot, we get back a new teapot with a value inside of it transformed, which is the base of something being mappable. Wait, pause, time out. Teapots have T inside of them, not numbers. That makes no sense. Well, that's because it's my teapot here. If I want numbers in my teapots, I'll have numbers in my teapots. If things made sense here, we wouldn't call it Fantasyland. Anyway, moving on now. Ahem. And if we have a method which returns another teapot, we can use pour to combine the two of them and return a new teapot. Wait, combine? That sounds a lot like something which might happen to be reducible. So you remember I said something which is pourable is both mappable and reducible? Well, here's where you figure out exactly how it's reducible and what we're doing so using rules. The first rule is left identity, but let's ignore that name. Let's call it join for now. Put simply, it means we can combine two pourable things, but how does it work? If you pour a value into a function, we get the same value as if we called it two functions directly. In other words, we have a way to combine two things which are pourable, in this case, two teapots. Well, let's start out real quick. And with method or a function which returns a new teapot after modifying the value passed into it. Did that value come from another teapot or from a number? We don't know. We just diligently prepare a new teapot all the same. So we make a new teapot and we pour its value directly into that method. Mind, we use method and function interchangeably here, but you're more likely to use methods and lambdas and Ruby, so do keep this distinction in mind. In the first case, we pour the value of a teapot into the add5 method, which would give us the value 10 inside of a new teapot. In the second case, we'd have add5, which gets the number 5 directly rather than pouring from another teapot. That also gives us back a new teapot with the value 10 inside of it, which means this will be true. Two teapots, both with 10 inside, are indeed equal to each other. But why is that important? Well, we want to be sure no funny business is happening if we pour the value out of a teapot. If we wanted the same value that was inside the teapot directly, like 5 here, it should be no different than if we poured 5 out of another teapot. What do I mean by funny business? Well, maybe someone thinks they've invented more tea out of the thin air. How preposterous. Can't be done. I should know. I've tried. Escher has too. These types of shenanigans will definitely fail our rule. The next rule is right identity, though let's call it empty for now, because it's very much like reducible. And the idea here is if we start with a new teapot with the value 5 inside of it, and we pour that value into a fresh new teapot, it should have the same value on the other side. It should be equivalent, right? Now, why is this important? It means that we can take a teapot with nothing funny happening on the inside and verify that if we pour into a fresh new teapot, it should be clean and not do anything surprising to the lovely tea we just poured into it. Because that would be a horrible shame. No, no, no. And that last rule, associativity, which is the same idea as grouping from earlier. It can look similar to functional composition from mappable too. It's fascinating how often these ideas overlap. So let's say we had two methods here, one which multiplied the value by 2, one which added 5 to the value and returned us new teapots for both of them. Now, if we were to take the initial teapot with the value of 5 here, and the result of directly pouring them into each other in sequence, it should be the same result as if we poured the original result into the multiply 2 method and then poured that result and add 5 with the original pour. But we can see it's equivalent, but it's very hard to read, isn't it? I'm not sure I entirely follow that. So look at it from this angle, and it may make more sense. However we choose to group these additions, we get back the same rule, and we get back the same results. But if it happens to replace plus with pour, instead we start seeing something very fun indeed. Why is this important? Very much because things that are reducible are very much like this. Isn't it fascinating how all three of these ideas come together? So let's see both mappable and reducible at the same time. I think we've discovered something fun here. But, Red, I am a naughty, naughty lemur. I've been lying to you this entire time. I feel I must come clean to you what this has all been about. But there's someone you should meet first. With that, Indigo gestured to opening the forest with a horrifying red fog emerged, eyes of flame glowing bright, so it approached waffling through woods, burbling as it came, the jaws that bite, the claws that catch. Now I must run, or Red would meet his match. Except the fog dissipated, and in its place was a small green cat with dragon scales, meowing happily. Huh. Oopsie. It's my great honor to present you to my new best friend and creator of these lessons, the Monad Walkie. You see, I wasn't entirely being truthful about the names of all these things. I might have stretched the truth a little bit. So mappable's idea is something can be mapped over while retaining its shape. It's true. However, the name is actually functor. The idea you can map over a context that it's an array, hash, promise, or a lot of things really. And sometimes you might see these other names where map can frequently be called fmap, wrap might be called unit, return, not that return by the way, or of. It's very difficult to look at the documentation for those things. Reducible was the idea that many things could be combined into one thing. The true name is monoid, mono meaning one, and oid meaning the manner of, which we can combine many things to become one thing. We might also see these other names for things, such as fold left, or mcomcat, or identity, and m0. And pourable? Oh, pourable is a fun one that you might already know where I'm going by now. Its true name is monad, and the idea that something can both transform and combine at the same time. What's funny is you've already used several of them. Wait, I haven't used Haskell, you might think. Oh, no, you got very close. Enumerable with arrays? Yep. Active record? Pretty dang close. Builder patterns in general? Bingo, there you go. And I'm certain people might take issues with my description here, but this is my tea party, and we're only using the descriptions I want. And naturally, these ideas come with their own names. Wrap is commonly used for monads, but maybe you see unit or return. Again, not that type of return. Pour? I made that up completely. That doesn't exist. Its real name is bind or flat map, which occasionally uses bind operator you see in Haskell. What's more fascinating is sometimes then is also a variant of bind if it behaves itself. Wait, so that's it? I thought that was supposed to be terrifying and impossible to explain. It's just a small cat? That was a monster? Anticlimactic, isn't it? They are so very cute, though. But didn't you gloss over a lot of detail in this entire talk? Oh, who cares? It's close enough to make the point that they're not all that terrifying. This is my tea party, and it's over now, so no one can do a thing about it. After all, monads are just monoids in the category of endofunctors. A crackling could be heard in the background as something broke. Because I still have time to let this talk, and those mysterious lemurs from earlier not once let something go. No, especially if Indigo goes off and says something like that. The mysterious lemurs. So we see the purple fog emerge, and the same group of mysterious lemurs come forth, summoned by those very words, the words which must never be uttered, and a whisper could be heard all around them. Monads, monads, monads. Endofunctors are functors in programming. They skip duplicative functors. They explain the entire thing wrong. Stop trying to use it in Ruby, they said. Indigo breaks in a cold sweat, for he knew exactly who these lemurs were and exactly what they were here for. They were lemurs of Haskell, and they had come to... Oh, Indigo! You should have let us know you wanted to learn more about monads. We would gladly teach you. There's so much to learn, so many rules to explore in the Ivory Tower, so much more to get into. But... And of course, now that you've opened the book without reading the terms and conditions, you simply must come. Rabbits, dodos, flowers, jabberwockies, and... Oh, no, this won't do at all. Indigo begins reading the book, looking for a loophole, but the binding spell had already triggered, and it was too late. Anyone who's seen the monad walkie and has said the words aloud must be taught the ways of the Ivory Tower, lest they try and do something irresponsible, like teaching others about it before they're ready. Right, Initiate Apprentice Indigo? Outro. So we find the Elder Master of the Lemur world all sitting happily at the tea party. Are we sure that was kind of us, Crimson? You know what the lemurs of Haskell are like. Oh, come on, it'd be a good experience. They're eccentric, sure, but we ruby lemurs aren't much better for being fair. No, the point is that those two get to explore a brand new world and find all sorts of new adventures. But I don't get it. Violet's normally so protective of her library. Why is that book in particular unlocked? With a familiar crackle and pink sparkle, Violet appeared in Indigo's chair, chuckling with tea in hand. It was about time for Indigo to learn a few lessons, and who better to teach him? Now that's just mean-spirited, and I'm the Dark Lord here. Violet continued to sip her tea, smiling to herself. Who said it was my idea? The Escher cat sat in her lap and simply purred. Isn't that right, Escher? So we find Red and Indigo initiating the Ivory Tower, Bastion Functional Programming, the home of all lemurs of Haskell. There we learn topics like category theory, monads, applicatives, and more. Red was certainly excited, but he could hear Indigo complaining the entire time about never opening another cursed book. And so we find the book safe, locked away deep within the library. But in the world of lemurs, there are many more hidden books, secrets discovered, knowledge is considered forbidden, just too plain strange to learn. We can still find them if we look hard enough. They may be strange lessons that we have not learned yet on how to program in Ruby. But many of those lessons have already escaped this library. Pattern matching, functional composition, there's more. What was once fantasy became reality. What was once strange became normal. So we endeavor to explore what is possible. Whether in Ruby or another language entirely, who knows? But we must always continue learning and venture out, even the most unexpected places. What is considered forbidden today may well become proper Ruby tomorrow. Ruby grows, and so too do we grow with it. So to wrap up, you can find me on various social network sites right here. And if you want, you can find all the examples in the Red and Fantasyland channel. Now, as far as credits, a talk like this has a lot going into it. So I had a lot of good fun with Gauche artists and others, gouache, I suppose, excuse me, and getting a lot of inspiration. Of course, this talk is very heavily inspired by Alice in Wonderland, of which I have several references in there. These tutorials and people really helped me bring these ideas to life. And of course, technical reviewers I've had over the past few months who helped me overcode content from the talk and had to suffer through all the horrible jokes. I apologize. I tested them on them first. But as always, before we finish today, talks like this would not exist without community. And Ruby is one of the most wonderful communities I know. From all those who have encouraged me, said a kind word, reviewed my art, watched early versions of the talk, or even said a kind word, thank you. But that community is a very, very fragile thing. And one must seek to protect those who would do it harm, intentionally or otherwise. How the most vulnerable are treated and joked about in our community speaks to the integrity and safety of that community. We must reject all forms of hatred without reservation. I know it's been hard lately, but I hope that this little story cheered you up a bit and on your merry way to wherever you managed to come from. With that, that's all I have for today. Thank you.